Okay, today I want to talk about the periodic table of the elements and how we use it to determine what an atom is what the atom's configuration actually looks like. Remember, we have three different types of subatomic particles, and remember, subatomic simply means smaller than an atom. And so the only thing that really could be smaller than an atom are the things that make up an atom themselves, because atoms are the smallest form of matter that we have that still maintain their properties. And so once we get beyond that, when we go below that level, then we have to think about things that are subatomic, the items that actually make up the atom. And so we have three items, if you remember, and I'm going to be using the smartboard to kind of demonstrate and talk about these things today. The first thing we have are protons. Now, one thing about protons is you can always figure out what the atom is in this periodic table by knowing that the atomic number, this top number, like it says 1 here, let's see, 2 over here, 3, 4, 5, 6, 7, 8, 9, 10, and so on. That number will always identify the number of protons that that atom contains. And remember, protons are always positive. They're found in the nucleus of the atom. Okay? There's only one other item that's also found in the nucleus of the atom, and that is going to be the neutron. Now, neutrons are not that easy to figure out. You're going to have to use a little math to figure that out. But let's go ahead and identify that. The neutrons, and they have no charge. They are neutral. And so if you just remember neutral and neutron, you'll remember that. Now, neutrons are also found in the nucleus. Now, both of these items are the same exact size, and they are what calculate the atomic mass of the atom. And so if you remember that those two items make up the mass, then we can figure out that this number right here, 1.008, 0.941, I'm sorry, that's wrong, 6.941, 9.012, those numbers identify what's in the nucleus. Now, to find the neutrons, you simply just round that number, the atomic number, and if it's 0.5 or higher, you round the number up. If it's below 0.5, then you round the number to what it is. So you just keep it the same. And then you simply just subtract the atomic number from the atomic mass. And so what I'm going to do here for hydrogen, for example, if you notice its atomic mass is 1.008. And so 1.008, we look and we see the number right next to the decimal is below 5. So we're going to keep the number as 1. Okay? And so we're also going to subtract the one up here that's above, which is the atomic number. That tells me the protons. And so if this number, the atomic mass, identifies the nucleus as being protons and neutrons, then if we simply subtract that atomic number from that, then we're going to arrive at the number of neutrons. So when I subtract 1, I end up with 0. Hydrogen is the only atom in the periodic table that has 0 neutrons. Now we'll find out later in a future lesson that there are different types of atoms out there that are called isotopes. And those isotopes, the only thing that's going to be different about them is their neutrons. But we'll save that for a future lesson. So let's take a look at beryllium. Beryllium, as you notice, is 9.012. Well, if you notice that 0.0 is going to maintain the 9. It's not going to round up to 10 because it's not 0.5 or higher. So when I take 9 and I subtract 4 from it, and we look at that and we say, well, 9 minus 4 is 5. And so 5 tells me the number of neutrons that beryllium has in it. Okay, so you never can be confident that that top number, the atomic number, will equal your neutrons. Sometimes it will, but I can guarantee you on tests and exams, and especially whenever a year-end assessment such as the STAR or an end-of-course exam comes up, they're more than likely, including myself on my exams, I'm more than likely going to choose atoms that I know that you have to subtract the two numbers to arrive at the right answer, just to make sure that you are figuring it out right. I don't want students to come in and automatically assume that that 3 tells me neutrons. That's incorrect. That 3 will tell me the number of protons, however. Okay? The protons will never change in an atom. Protons will always remain the same. The neutrons as well. But just remember, the neutrons you always have to subtract the atomic number from the atomic mass. Okay? So let's kind of kill this for just a second. That didn't work out. Let's try that again. Okay, so the only remaining subatomic item that we haven't talked about is the electron. Okay, if you remember, Schrodinger figured out that the electrons actually move in energy levels, and so the electrons fill up the different rings within the orbit of the atom. And so, if you remember, the first ring can hold 2 electrons, and the second ring can hold 8, and then it continues up from there. We really focus on those 2 energy levels in middle school, so that's where I'm going to focus my attention. And we always remember that phrase 2 and 8, and that helps me to remind myself that the first energy ring will hold 2 electrons, the second energy will hold 8. Okay? And so the electrons, of course, because we already had a positive charge from the proton, we have a neutral charge, which is no charge, from the neutron, and then now we need to balance that positive charge. So the way we balance the positive charge is with a negative charge. So electrons are negative. They are found outside the nucleus. Now the thing about electrons is we understand that atoms are so infinitely small that we can't see them with the human eye. We can't even see them with a microscope. We have to get to really high level technology. We have to get to an electron microscope that is designed to actually see to the atomic level. And so those microscopes are millions and millions of dollars. You still can't see it with your eyes. It has to be computer generated. And so these atoms, are super, super small. And so I just always remind my students, if you see a dot, a period at the end of a sentence in a textbook, that little bitty dot has more than 1 million atoms in it. And so when we think about that, we're talking about things that are extremely small. But the electron, compared to the overall size of the atom, the protons and the neutrons, the electron is so insignificant in size compared to the proton and the neutron. So we don't even calculate the electron in the atomic mass. It's not even considered to add to the weight of the atom. Okay? And if you notice, these atoms always go from 1 to 2 to 3 to 4 to 5 to 6. If you notice, their atomic mass is always increasing, which means as we go from left to right and from top to bottom, these atoms are getting heavier and heavier and heavier. Okay? That's why we find lead way down here, okay? Because lead is a heavy metal, right? Gold and silver and tin and aluminum, all those are lighter than lead, and so you're going to find them as a lower number of the atomic mass. Okay? So these electrons are simply negative. But something else we have to remember is in the periodic table, all of these atoms in the periodic table are considered to be neutral, which means that their overall charge is 0. Okay, so what I mean by that is, let's say, for example, lithium. Lithium, we know, has 3 protons. That's positive. Well, to balance that, to make the charge 0, it must have 3 negative items to balance that charge. So if we take 3 electrons, which are negative, and we subtract those 2 numbers, we're going to arrive at 0. And so we know that lithium, for example, has 3 electrons. We can do that for any one of these atoms. Magnesium has 12, sodium has 11, beryllium has 4, and so on. So not only will the atomic number tell me the number of protons, the positive items, because I know the atom is also neutral, then I also know that that number will also tell me the number of electrons. Okay? Now the only thing that changes in that is when an atom goes through a chemical change or a reaction. What happens is when these atoms form compounds, which we are going to get that lesson pretty soon, when they form compounds, what they have to do is either take away electrons or gain electrons from another atom, okay, or give away electrons to another atom. And so when that happens, it creates a bond between them, or they share the 2 electrons or 3 electrons with each other, or whatever it's going to be. However many electrons they might be sharing with each other makes that bond even stronger and harder to break apart. Okay? There's more energy wrapped up in those bonds. And so one main component that you need to remember is when these electrons come together or break apart, it takes energy to do that. And that's why we usually end up with, in a lot of chemical reactions, heat given off or the item turns cold. Okay? Those are exothermic and endothermic reactions. So when you see all that heat and energy given off, it's because the bonds are breaking and reforming to form a new compound or a new product. And we are getting to that level. We will eventually be doing some labs that involve some of those things. But right now we're still laying the groundwork for why these reactions happen. Okay? So just remember that these electrons in the state of the periodic table will always equal the number of atomic numbers. Okay? So it's not until we get into atoms that are going through a chemical change that we can't really look at that as the identifying factor any longer. Because what we end up with a lot of times is an atom that has gained electrons. If it gains electrons, if we start adding electrons to this atom right here, it's going to be overall negative. If we start taking electrons away from it, then that that atom becomes positive because we don't have enough electrons to balance the protons. Okay, so we'll touch on that at a much greater depth here in a future lesson. But for right now, what I want you to understand is just how this table is kind of coded and how it's arranged, and some of the primary things that we're going to use with it. So just as a refresher, let's go back over it just one more time, and we'll kind of make this quick. If we look at this, the atomic number, that 1, it will always tell me the protons. So we know that hydrogen has 1 proton. And if we look at the atomic mass, that's the combination of protons and neutrons. Well, it's 1.008, so I'm going to just round it to 1. So the atomic mass there is 1. I subtract that 1. I get 0. It's the only atom in the periodic table that has 0 neutrons. And we know that this atom is neutral, therefore it must have an equal number of positive things as it does negative things. So since it has 1 proton, it also means it has 1 electron, which is negative. Okay? So for example, let's use another one, magnesium. Okay, magnesium has an atomic number of 12. So that tells me it has 12 protons, which are positive. Since it's got to be a neutral atom, it also is going to have 12 electrons, which are negative. Okay? And then I know that its atomic mass is 24.31. 24.31 rounds to 24. So 24 minus 12. So if I subtract that, 4 minus 2, 2 minus 1, it also has 12 neutrons. And those have no charge. Okay? So we understand that we can't always rely on the atomic number to tell me neutrons. In fact, we should never rely on that. We always have to subtract. So the main component of neutron and being able to find that neutron is to be able to subtract those two numbers. So I hope you get a lot out of this lesson. I hope you'll review it. This is definitely going to be something you'll need to be aware of on the upcoming exam. And so just review this video at your convenience to be prepared to take this exam. You'll also need to know how to draw the atoms. So make sure you look back at that YouTube video that shows you how to draw the atom and how to put the electrons in the correct energy level. And once you have those two things down and you know these basic things about the periodic table, then you'll be pretty well set for the exam coming up on Friday. We've got a lot more to learn about this periodic table, but this gives you a quick introduction on some of the main things we need to know. Okay? Good luck, and just review the video as you can. If you have questions, let me know. I'll be available through email, or you can contact me in class. Or come to tutoring. That's always a great way for you to kind of get a little heads up on the things that you're questioning. Anyway, wish you luck. Hope this video helps you out.